Now, whereas Gaussian elimination got just the bottom left-hand corner to all be zeros, the reduced row echelon form, or the Gaussian Jordan elimination, also gets zeros in the top right-hand corner and makes the diagonals all 1. So if we imagine an augmented matrix that was a 2 by 2, and you had this as your result, if you got it into reduced row echelon form, you would know right away from here that x is equal to 2 and y is equal to 3. And with a 3 by 3, if you got it into reduced row echelon form like this, you would know right away that x is equal to 5, y is equal to 6, and z is equal to 8, or whatever letters you were using. As far as an order goes, you start with Gaussian elimination because you are going to get that bottom left-hand corner of zeros first. So what you're going to do is you're going to get this first. With your 3 by 3, when we did our 3 by 3s, we noticed we got these ones first, and then I'm going to call this 1.5. You could call it second if you'd like, but we're going to try and get that bottom corner first. And when you have a 3 by 3, you sort of have to do it in 2 steps. You have to get that first column, and then you can get the second zero next. After you have all those zeros, the next thing you can do is you can divide this row by whatever number is there to get that 1 to be a 1. So we're going to circle that bottom number 1 to be second. After you have that, just like sort of a mirror image of what's happening on the bottom, you're going to get that third and that 3.5 with the 3 by 3. And the last thing you're going to do is get those to be 1s. In fact, this middle one here, if you want, you can make it a 1 even earlier if you'd like. So it's sort of an order of how we're going to do it. We're going to first get our bottom left-hand corner to be zeros, and then get our top right-hand corner to be zeros. And that's our plan. So with this first example, we want to convert it to reduced row echelon form. Our goal is to get that bottom left-hand corner to be a 0 first. So we need to change row 2, and row 2 can get changed by taking row 2 and subtracting row 1. Or you could have done row 1, subtract row 2. Either way, you would get a 0 there. So if I do this, my row 1 isn't changing. So it stays as 1, negative 2, 10. But when I do row 2 minus row 1, I'm going to get 0 here. 4 minus a negative 2 is going to give me 6. And 16 minus 10 is going to give me 6 as well. Second thing I want to do is get a 1 in that bottom right-hand corner. So I can do that by taking row 2 and make it equal to row 2 divided by 6, or multiplied by 1/6. Again, row 1's not going to change. It's still going to be 1, negative 2, and 10. But now, when I divide by 6, I get 1 and 1. So now I've succeeded in getting the bottom right-hand corner to be a 1. The next step, I want to get that top right-hand corner to be a 0. So now I'm not going to be changing row 2 because it's already done. But now I'm going to make row 1 equal to row 1 plus 2 row 2s. Well, the nice thing about this bottom 0 here is when I add 2 of that to this one, it's still going to be 1 here. 2 of those plus that is 0. 2 row 2s plus row 1 will be 12. So now that we've got to this point, it's telling us that x should be 12, y should be 1. If you want to know if you're right, you can plug it back into the original equation. Our original equation here says that 1x minus 2y should equal 10. Does that fit with those numbers that we have? Does it work? And the second equation says that 1x plus 4y should equal 16. And if you plug x is 12 and y is 1 into both of those, we realize that yes, they do fit, they work, so these are both the correct answers. All right, here's one for you to try. Now, sometimes the order that you do it will be different than what I have up here as a possible solution, and that's fine, because what you choose to do as your row operations may be slightly different. But usually in the 2 by 2, it's very similar. So if you've got this one and you've checked it, you can try the next one. If you want to check the next one, okay, so if we move to the 3 by 3, first thing I would do in a 3 by 3 is when I'm about to set it up, instead of taking an extra time to rearrange some of my matrices, I'm going to look at this third equation, which is the 1, -2, -1, 2. I'm going to already put it as my top row, because I think it's going to make my life easier already having a 1 up front. So I took the third equation and I just wrote it in the first row, because it doesn't matter the order of your equations. Then the other ones you can put 4, 1, and 1, 2, -1, and 2, 4, 1, 1, and 5, 2, -1, 2, and 10. It is not a bad idea to take a slight second every time you do an operation just to check to make sure you've done something right. Because if you make one small minor error, and it might be as small as copying down the question wrong from the original question, or one arithmetic mistake as you're going through, you're going to do a ton of calculations with that mistake only to find out your answers don't work, and then you have to redo everything. And that is a pain, and everybody here will experience that at least once as part of working with matrices. But if you do that slight little check, are my equations exactly as I have them written here? Have I remembered all my signs? Are they all correct? Just to make sure that they're fine. That little bit of checking could save you 10 minutes later if you catch a mistake. So it takes a little bit longer while you're doing it, but could save you time later. So to start off with, I'm not going to change my equation 1, but I am going to change my equation 2. My row 2 is going to subtract 4 row 1s. And that will give me a 0 here. And my row 3, I'm going to do at the same time. I'm going to take my row 3 and subtract 2 row 1s, because that will give me a 0 there. So my first goal is to get zeros in that column. So now I have to do the math. Well, for row 2, I'm subtracting 4 row 1s. That'll make this a 9. Subtract 4 row 1s will make this 5. And that a negative 3. Row 3, subtract 2 row 1s, so negative 1 plus 4. 2 plus 2. And 10 minus 4, 6. So our next goal is to get a 0 right there. Can you see that you could take 1/3 of row 2 and sort of add it to row 1? That would work. However, it might be easier if the smaller number was first. So we have some options here. I might take the time to just switch row 2 and row 3, just so I don't have to deal with fractions, because my smaller number is there in row 2 and row 3. But it wouldn't be wrong if you decided to work with some of those fractions. So now I have 0, 3, 4, 6 listed there, and 0, 9, 5, negative 3 listed there. And you guys will speak up if I make a small adding, subtracting mistake, and I missed it while I checked, and you see it, you'll tell me, right? So we don't go through the whole equation, only to find out at the end that it doesn't work. So now I can take my new row 3, and I can take row 3 minus 3 row 2s. Well, row 1 still isn't changing. Row 2 isn't changing. And when I take row 3 and minus 3 row 2s, I'm going to get 5 minus 12 and negative 3 minus 18. Things are looking good. So now we've succeeded in getting the bottom right left-hand corner to all be zeros. The last thing we need to do for row 3 is divide it by negative 7. To change that to a 1. Now that we've basically finished step 2, we've got all the bottom corners as zeros, we got the last number to be a 1. Now we can go about and think about making these two 1 zeros. So we're going to change row 1 by doing row 1 plus row 3. And we're going to look at row 2 by making that row 2 minus 4 row 3s. So that will succeed in getting both of those to be zeros. And if I take row 2 and subtract 4 row 3s, this will still be a 3, and that will still be a 0. And 6 subtract 12 will give me negative 6 there. Again, if I add row 1 and row 3, the nice thing now that there's a bunch of zeros is these will not change, but the answers will change because 2 plus 3 makes 5. At this point, I only have one more 0 to make. Life will be easier if I take that row 2 and divide it by 3. To make that middle number a 1. And now the last thing that I need to do is get that 0 in row 1. I can do that by adding 2 row 2's to it. So there's many different things that you can do to an equation. But one of the things I hope that you see that I'm doing is I like to, if I'm changing row 1, I keep row 1 the way that it is, and then I add or subtract another row to it. That seems to be a pattern that I've done in all of my calculations when I'm changing a row. So it's a nice systematic way to do it. It's not that you have to do that every time, but it's a nice way of setting up your equations. So again, the only row here that's changing is row 1. And now that we only have a 1 here, when we add 2 of those row 1's, these become 0's. And 5 plus -4 gives us 1. So in our original equation here, we now know that x is equal to 1, y is equal to -2, and z is equal to 3. And if we want to check if those numbers work, we can plug them back into our original equation. Four minus 2 plus 3 is 5. 2 plus 2 is 4, plus 6 is 10. 1 plus 4 is 5, minus 3 is 2. So all 3 of those equations work with those answers. So we know that our solution is correct. Now if we look at everything that we did, it's a lot of writing. It's a lot of minute calculations that we went through to get our final answer. And that's how these reduced row echelon form ones are. The 2 by 2's are a lot less work just because there's less zeros. It's not that reduced. If I could give you a 4 by 4 and you could reduce that one all the way down, so then you have the first column, then the second column of zeros, and the third column of zeros, and then do the same process on the way back. But here's one for you to try. Okay, where I see people having troubles, I see most of you were able to get the zeros in the top corner, and then you were having troubles with that 16 and that 12. So one thing you could do to make those troubles go away is there a way that I can make those numbers the same? If I multiplied equation 2 by 3 and equation 3 by 4, they would both become 48s. Now those are bigger numbers, but then you could subtract the 2 equations and get your answer to be 0. So I'll leave it, yeah, I can go back up to there. I'll leave that up there for a bit. Here's a little bit more information. So you divide row 3 by -17. I also divided row 2 by 3 to get back to where it was. There's maybe your mistake. This one, oh, this one should be -3. Yeah, and that shouldn't change there. There is the rest of the operations to get you down to reduced row echelon form. I don't know why it's called that. I'll have to look that up.